Hey YouTube, welcome back. Have you ever wondered how Yelp finds the best restaurants near you almost instantly? How does it search billions of places, show reviews, and return results in milliseconds? Today, we'll break down Yelp system design and relieve the tech behind location-based service like Yelp. So, let's assume that you are in your system design interview and your interviewer asks you to design a proximity service like Yelp. The first thing you need to know before doing anything in your system design interview to know what are we designing basically. If you don't know what Yelp is, feel free to ask your interviewer what is Yelp. So let's try to answer this question. Yelp is a platform that helps users discover, review, and connect with local businesses, whether it's searching for restaurants, writing reviews, or checking rating. Yelp helps everything happens fast and reliable. Let's talk about the key challenges that makes designing a system like Yelp quite difficult. We need to talk about that. We can talk about that in the functional requirements and the non-functional requirement. Will be our next step. In any system design interview, first you need to understand what are you designing. The second thing, you need to figure out you with your interviewer the functional and non-functional requirements. After that, we establish a high-level design and we go deep in each component. So in the functional requirements, we need to have to give the ability to user account. We have two types: businesses, owners, and general users. We need to add search nearby places using GPS like latitude and longitude. We need to have a feedback system like reviews, rating, photos, etc. In the non-functional requirements, we need to make our system pre-scalable, highly available, consistent, and very low latency. So, how can we do that? Let's start first by the client. Okay, it's pretty small. Let's start first by the client because everything starts there. The client will try to send requests to our servers to send read or write requests, and we need to know how could we manage these requests. So all the requests will be go through a load balancer, which will distribute all the incoming requests across the servers. However, let's assume that what should we do next? We need to think about something which is quite important. If we thought about Yelp, the read ratio in Yelp is much higher than the write ratio. So to make sure our system handles everything in the best way possible, we will use two types of servers. First, we'll use write servers. Okay, and let's give them different color here. No, yeah. Let's make it black. And we will use as well read servers. And we will talk about why exactly we're doing this. Oh, that's too big. Okay. Okay, so we have write servers, we have read servers. Let's make this bluish, I guess. It will be better. Okay, so why we doing that? Why we separate read and write servers? Do you have an answer? Stop the video and put the answer in the comment section below if you know it. So Yelp system handles significantly more read requests as we said before than write requests. By separating these requests, we optimize resources usage and reduce latency. The read servers handle all search queries, find cafes within 5 miles, etc. forward search requests to QuadTree servers and return results to users. The right servers process all updates such as adding places, reviews, or ratings, update the SQL database and blob storage. We will talk about them later for structured data and images. Right servers also keep the QuadTree servers updated with the latest place and data. So we separate reads and writes, ensures that frequent read requests don't overload the system, improving scalability and the performance of the system. The second thing, we said that we need to, some reviewers could add some photos. So how we will store these photos? We will store the photos in a blob storage. We could use like it's Amazon S3 for that. Let's give it like, I don't know. Let's give it this color. And this will be a blob storage. Okay, let's give it like and also we need to have like a relational database for users, maybe users, places, reviews, photos, and more. So we add a relational database. We need, of course, a relational database. So this will be our own, let's give it a different shape. So this will be a SQL DB or a relational database, whatever it will be you want to make it. Okay, so can I make this one to be here? Yeah, that would be better. Next, we need to think about something which will be, okay, how could we break down the entire world map into smaller manageable segments that make searching for places much faster? How can we do that? We can do this by basically using a segment servers or segment producer. Segment producer, and it will be connected as well with like with two things. It will be connected with let's give this one a third party map information. Let's call it MI, map info. That's okay. Exactly something like that. And let's give it a different color. Let's make it like okay. And also it should be connected with NoSQL database because a key value store. And we will talk about why we're using this key value store, but just be aware with me. We said that we will do database like that, a key value store, key v. Okay, let's talk about the segment producer. The segment producer is responsible for breaking the entire world map into smaller manageable segments. This makes searching for places much faster and more efficient. It acts as the starting point of Yelp system. So, how it works? It communicates with the third party. It communicates with the third party map service like Google Map API, for example, to get that map data. After that, the map is divided into fixed size regions or segments such as 5 and 5 by 5 miles. After that, these segments are stored and updated periodically to reflect any changes, like new businesses or places or something like that. Without segment, the system would need to search billions of locations, which is inefficient. By reducing the search space, we drastically improve the performance. And we're using here the a key value store. But why are we doing that? We're using a key value store stores the segment specific data for faster retrieval. We have the key value store. The key will be the segment ID, and the value will be the list of places within that segment. The key value stores also hold a QuadTree information, allowing efficient access to spatial data. So, what should we do next? I guess let me just review everything here. Okay, I guess we are done with the read thing. Okay. Let me okay, I'll try to put this one here, and this one should be like that. I hope my system doesn't look trash. Um, no, 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 no. No, it looked trash. It looks trash. Okay, let's leave it like that. Okay, let's leave it like that. I guess we are done with the write. Let's focus on the read. So in the read, we will have first we said that the key value stores will get the data from the quad tree will get the data from the key value store, the quad uh, tree servers, and we need to make this like that, and we change the color of it to make it and the QuadTree servers will be connected, should connected with a cache system, because we said that we need to make everything very low latency. So with very low latency. So if we used cache, the cache will cache the frequently accessed data. So we improve our cache. And next we should connect it with some, no, not like that. We should be connected with, no, delete and delete, please. Let's add here. It will be, what's going on? Sometimes I don't like how mirror works. Okay, so we will have like what we call um double G aggregator servers, and these aggregator servers should be connected with the read servers. No, yeah, yeah. Okay. What is this? I guess we have the cache. We should have one more thing though to make everything as best as we want, because a quadtree as well should have access to the oh, okay. I guess we should make it like that. The quadtree should have, but I would say something that, because we will need, we said it's quite important to have our rating calculator. Calculator, let's call it like that, and it should give it a different color so it will be easier for you guys to see what's going on here. And the rating calculator will be connected with the okay, I guess this is great. Okay, let's talk about the system. First, we have let's talk about the quadtree. I had to add everything because the quadtree, we are talking next about the quadtree. The QuadTree servers manage the spatial the spatial data by dividing regions into smaller quadrants. Each server holds a QuadTree, a spatial data structure used to store places within segment efficiently. Let's understand how it works. Each node in the quadtree represents a segment. If the number of places in a segment exceeds a certain threshold, like for example 500, for example, it will split into 4 child nodes. And if you don't know what a quadtree is, I highly recommend you to stop this video right now and watch my previous video that talks about quadtrees. The quadtrees are replicated as well across multiple servers to ensure highly availability. A leader follower strategy is used for replication, where changes are synced between nodes. Each server can quickly retrieve the relevant places based on the user's location, like latitude and longitude, and the search radius. For example, imagine you have searching for cafes in New York City. The QuadTree server starts to at the root node and traverse down the relevant segment that contains cafes within your search radius. And the QuadTree makes searches highly efficient, especially for unevenly distributed places. In densely populated areas, QuadTrees split nodes into smaller segments dynamically, ensuring quick and optimized searches. Yeah. And if we want to talk about what are the aggregator servers, the aggregators collect the results from multiple QuadTree servers, combine them, and return the data before send it back to the user. The QuadTree servers, for example, return a list of places to the aggregator. The aggregator filters and sorts the results based on relevance, distance, or rating. Finally, the refined results are sent back to the client, which is the user app or website. Aggregators ensure the results are comprehensive, accurate, and stored based on user preferences like top rated places or closest locations. And we talked about the cache. We have the rating calculator because if we want to calculate the rate, it's pretty simple thing. So what next should we talk about? Let me think. Okay, so okay, let's talk about the scaling. We can use data partitioning to scale systems, like in the SQL database. We can partition data by regions ID or by place ID. If we want to handle growth, we need to regular updates. We need to add regular updates to the QuadTree and segmentation. We introduce caches to store popular spaces. We did that. We need to use a rating calculator service to pre-calculate ratings, update ratings during low traffic hours. So this is why using a calculating service. Also, if we wanna talk about how Yelp will work, searching for nearby places, the load balancer will route the search for the read servers. The read servers will query the QuadTree servers to find places in the user specified radius. The QuadTree servers send results to the aggregators. Let's make sure that the QuadTree service, it's dumping that. The QuadTree servers send the results to the aggregators, which refine the list and return it to the user. In terms of how the adding places will work, write requests are routed to the right servers. The right servers updates relational databases for structured data and the plop storage for the image. In terms of the making segments, the segment producer periodically updates segments using third-party map APIs like Google Maps API, for example. What next should we talk about? Let me think. I guess we are done. Let me try to think. Did I move anything? Did I lost anything? I guess we're done. Yeah, we're done. So, okay, if you think that there is something important that I didn't say, just feel free to give me a hint in the comment section below. So to summarize everything, we have designed a system for Yelp that handles billions of places efficiently, ensures scalability, and minimizes latency using optimizations like QuadTrees, caching, and load balancing. This design helps users to find the best businesses nearby instantly. So, if you found this video helpful, don't forget to like it, subscribe, and hit the notification bell in the comment section, and hit the notification bell so you never miss any video. And leave a comment and let me know which system design you want me to explain next. So that's it for this video, and see you in the future, guys.